Hey, what's up, guys? Yeah, so in this video, let me just create my own note about linear time sorting. Okay, so previously, I think I have a video that describe the proof of the comparison sorting. So the fact in the comparison sorting is that it has a lower bound. So it has a lower bound that you want to sort an array. So you have an array with length n, and a lower bound with n log n. And the example will be the merge sort and also quick sort. Okay, and yeah, so this and today I want to briefly review two standard counting sort. Okay, so sorry, two standard linear sort. Okay, so which at these two situations that basically your array, your range of this array is a small integer. So are small integers. Okay. Okay, so yeah, so let's talk about the first linear sorting, which is a counting sort. Was the first one, which is interesting, is a counting sort. Okay, so counting sort is very simple. That you just imagine that you have an array. Okay, maybe 1, 3, 2, 5, 7, 5, 2, 3, and you just go left to right, and let's say, and you create a dictionary. Right, so you can create a dictionary, which you just count how many, right? So, and then let's say originally you already know it must from 1, 2, 3, 4, 5, 6, 7, okay, up to 7, and then you can create a dictionary. And you just count how many of them. So you can see 1, 1, and then you see 3 have 1, 2 have 1, 5 have 1, 7 have 1, 2 have 1, 3 have 1. Okay, then you just output the results. Okay, so you just output the result basically 1, 2, 2. So you get 2, 3, and 3, 3, and 5, 7. Okay, so this is just counting sort. Okay, so so the sort range. So the first is sort range is based your array range is at maybe from 0, 1, or 2 up to k minus 1. Okay, and your algorithm just basically first build a dictionary, and then you just go through the array, right? You just go through the array. Simple speaking, you just go through the array. You can find the algorithm on a textbook, right? So I will not write. I just write the pseudocode or the idea with those building and go through the array and the output. Okay, so the complexity will be, suppose there are 1, 0, 1 to k minus 1, right? So you need to build a dictionary k plus n. Okay, because you need to spend time on building this dictionary, and then you need to scan this dictionary, right? So it contains the OK plus n. Okay, so which is linear? This is linear if this case order of n or theta of n. Okay, another linear sort is also usually used is the radix sort. This sort is very interesting. Okay, so the idea is that you first choose base b. Okay, so b should be greater than 1, and let's say you have a range. Basically, it belongs from, let's say, maybe I start from 1 to up to, let's say, k. Okay, and so you can use, so each number, you can use a log bk plus 1 bits to represent. Okay, then you just sort. So first you just sort the least significant digit, and then the second you just sort the second, I should say the least second, or the second significant digit, and you keep going. So finally, you just need to sort the most significant digit. Okay, so then done. Okay, this looks very weird. Let me just quickly provide example. So for example, let's working out maybe this. Okay, so the first step is that I just sort the I choose base 10, and I sort this with the least significant digit. So it's 2, 3, right? So I should write this one and this one, maybe this one and this one. Okay, and after that I can sort the significant digit like this. Okay, then I will get 5, 2, 3, 4, 2, 3, 1, 2, 4, 7, 3, 7, 2. Okay, then next I just sort this digit. Okay, so I get 1, 2, 4, 3, 7, 2, 4, 2, 3, 5, 2, 3. Okay, it's amazing that this works. Okay, yeah, so this just ready sort. Okay, so so and from each sort, so for each step that we use a counting sort. So let's say this I call this D. Okay. So now let's count the complexity, which is very simple. Okay, since we use counting sorts, so we get n plus k. Okay, but in this case that we have at most b, right? So in this case this case b. Okay, so this case b, and the times d, right? The number of digits because we need to round the steps, right? D steps. Okay, so it's a on plus b log bn to bk. So get n log bk plus b log bk. Okay, in the extreme case, okay, so you want to prove that you want this to be linear, right? So the first example, the simple way is to just choose b to n. This you can rigorous prove this, but it's not important. Okay, so you get n log n k. Okay, maybe 2. Okay, so let's say if your k is n of O1, basically it's a polynomial in n, then this will be 2n times log n of O1, which is 2n. So it's linear in n. Okay, so this is the standard 2 linear sorting, and yeah, that's it. So this is just my quick recap of this 2 linear sorting algorithm. See you guys next video.